So hey, hello guys. Um, Today we're gonna solve a 1100 rated codeforces problem, and I'm not really very comfortable with 1100, so I'm just trying. I don't know I can solve it or not, but just gonna give it a try. But yeah, I'm making this video so that I don't cheat, and also I stay focused with that question. Like I really wanna solve that question. Let's see. So this is the question. Let me just check it. Yeah. A survey is a continuous part of an array. Part of array. Okay. Eureka found. Eureka recently found an array of length and become very interested in finding the maximum sum of non-empty survey. Maximum sum of non-empty survey. Okay. There are so many surveys and maximum sum. Okay. However, Eureka doesn't like consecutive integers with the same parity. So the survey he choose must have alternate parities, okay, for adjacent elements. That's good. Hmm. For example, 1 to 3 is acceptable, but 1 to 4 is not acceptable because it's parity same. Like 1 after that 2, it's okay, but 2, 4, it's not. You need to help with finding maximum sum of such series. So what I have to print? TNA, okay. Um, what I have to print is the maximum sum of this array, and n is 10 to the 5, so n log n is maximum, right? N square root n or n log n, and mm, what's Spanish? Found, recently found an array A of length n. Very interesting. Accept some of how would it just the same parity, so seven if there are no such surveys, so there is always that type of survey. Maximum sum of survey. Okay, the answer is okay. The maximum sum of survey, and that survey should be parity should be different, right? Like for example, at here parity are different. So if all are different variety, what I will gonna just do? I'll just gonna do sum the all. Okay, this same parity. So I'll just gonna take the 9 and 8, right? Yes, yes. Here different variety, different variety, different variety, different variety, different variety. But I think the sum is not total because there is negative integers also, right? So I should choose some portion. So because I need some maximum array, right? Maximum sum, right? So I don't want to take this -4 because this -4 will reduce my sum. And what even I want my sum to be maximum as possible. So I'll take this 5 and 0. I'll take this one and I'll take this 4. I think this will gonna give me the maximum answer, right? 4, 5, 9 minus 1, 8. Yes, 8. Okay, this is how it's up. I think I understood the problem. What's going on? -1, 2, 4, 3. So again 2 or 4 is will not gonna work. So either the answer is 1 2 minus 1, which is 1, which is, or 4 minus 3, which is 1. So answer is always 1. This is always 1. 4. Okay, 4. Why 4? How 4? Okay. What if I just choose this integer? This is also 7. Okay. For 101, 99. So the 101 minus 99 will always gonna give me some small value than 101. So 101. Yes. I think I do understood. Let's just open Excalibur. Whatever it is. Just. Oh, whatever. Okay. For this. Okay. 10. This. So I want maximum sum. So let's take this example. And I'm just gonna paste it over here. And I'm gonna take one more example where the sum is only the maximum one. So like this one, paste it over here, and we're gonna take this one also. Yeah, these three examples should be enough for them to understand the problem. To find logic. I know I'm solving very slow, very slow. I'm not saying I'm very fast with this type of problems. I really need to understand first, like from basic, right? I'm really not strong with integers. Just only integers. Okay, let me check. For this answer should be see minus 10. We should exclude minus 10. Okay, based on some as maximum as possible. So we should include the all What is a survey first of all? Contiguous number of elements. So I want a contiguous set of elements which has less amount of negatives and higher positives values, which is see 10 6, a very good sign. 7 9 will not gonna exceed my 10 6, or will uh, same value. 7 2. So I think I always should take this 10 and 6. It will gonna give me 16. The maximum answer is 16. Can I increase it more? This will also gonna give me 16 minus 10. 16 plus 16 minus 10, which is what is 16 plus 16 minus 10? Uh, so 22, I think. Yeah. So the answer is 22. Texas King is 22 here. Yeah, I choose this area. Why it's 10? I got more than 10. Why it's 10? Wait. The so however, अच्छा same parity. I forgot about the parity thing. The 10 6 will not gonna work. It just not gonna work. 7 9 will gonna work. No, 7 9 will also not gonna work. So I should choose some different parities. So let me check. Both have different parities. The answer is 5. Same parity. Different parity. Answer is so small. Answer is not possible. Hmm. I want different parity and the answer is 10, right? So maybe 7 to the should that not 6 minus 1. This one is giving me the maximum possible. 7 minus 6 7 2. Minus 6 7 2 will gonna give us no. It's giving me a very small value. 3 no. But 10 should just different parities. If I choose no, I can't choose this thing. Can't choose this. Let me check. Can choose this, yes. Give me very small answer. Can't choose this, yes. No. Can choose this. No. No. Yes. No, 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 I can't choose this. Sorry. Can choose this, yes. Can choose this, no. Yes. Yes. 3 still now maximum. Yes. No. 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 Yes. No. 4 till now. Till the maximum is 6. So, as I am seeing, okay, I got it. All of the, no matter how many surveys I make, the answer is always less than this value, 10. The sum is always less than this. So the maximum sum is 10, the array, the element itself. Okay. Now the question is, how do we solve it? What approach? How do we solve it? If I try to check for if I try to check for parities, it will gonna take n time, and after that, inside that n, I have to run another loop for checking sum. So O of n square, which is not a very sufficient way to solve it. Okay. Hmm. What should I do? Uh, let's go into this example. 9988. So I'll come here. If parity is same, at first I can do like this. See, this is always gonna be my answer. Okay, the maximum element, obviously. Now I have to find all such combinations. If the combinations of sum is greater than my max element, then that's the answer. If not, then this is my answer. This is very simple to understand. But now, how do I find the main thing? For obviously, if uh, there's no question in it, if n equal 1, just c of 0, where is it? C of 0, and then let's check and try to think about it. What should I do? If there is negative integers, it will always gonna reduce my value. So I don't want to take negative integers. I always want to take positive integers. But the thing is, I think for the same parity, not this one, 1, 2, 3, 1, 2, 3. Yes. For this one, I think the answer was like this. So even if I am taking a negative integer, even if I am taking, sum is increasing because 4, 5, 9, and this negative integer -1 will gonna give me 8. That's the thing. So what should I do to check this one? This condition shows that there is a negative inside of two positive. Parities are working correctly, but okay, when parities are working correctly, but if I take that negative integer, it's not reducing my value. Instead of it, it's increasing my value. So the negative integer should be the negative integer should be less than the negative absolute value of negative integer should be less than what It is -4 or -5. It always, it will not gonna work. Right. So the absolute value of negative, this negative integer in between two positive integer where parities are working, this absolute value should be less than minimum of these two, 5 or 4. Then I can take. Then I can take. So that I can only take if this minus this value over here is this absolute value is less than 4 or 5. If it is, then I can take. If there are multiple negative values, for example, but if there are multiple negative values, so I'll gonna just take the sum of all of their absolute values, and I'll check the sum is less than the minimum of both of the side, minimum of what minimum of this element or this element. Yes, so sum should be yes, so now how to solve it? If it is, take it as a value. If it's not, don't take. No, it's not. The values are not same. Take the maximum till now. If the parities, if the parities are not same, I'll do two, four, three, four, seven, under four, nine, minus one, minus two, 5. Yeah, it's okay. 6, 10, 10, then we take 8 and 2 over here and 1 over here. Okay, this needs some just check. The answer should be check parity. That is nothing over. So this is my maximum. So then I'll come here. I'll check the parity with the next element. Is it go to yes? If parities are matching, then go to the next one. Then take its full sum. In square, my loop is running for tell my loop will run for in square. Now, if for example this condition, I'll come at 1 and I'll go to until unless my parities are working sum. So it will gonna decom so can't I do it on one run? So, say For example, there is one base not 4, and for example, there is a list. There's 4, there is 2, there is 1, there is 4, 4 minus 1 minus 2, 6, 8, 1. What can I do? Okay. Um, yes. So just do the inside stuff. Here, practice one also. Parity. Okay. So this parity is not almost some. Unless we should store this value. It's the parity set. For we'll just gonna see this. So, sample set. When one is there, I can just say um, I got an idea, but I don't think that is correct. But I'll just anyway, I'll just implement it. I don't think it's correct. So equals 0, x equals 0, for example. Okay, not 0. We just start. I'm saying if the parity of the previous element is not equals parity of the current element, if this thing holds, then just sum plus equals to a of I minus 1 plus a of I, just do that, and else make sum as 0. Before doing that, mx equals to maximum of mx sum. uh, Answer equal to maximum of answer comma mx c out answer. I don't know, it will not work or not. It should not work because obviously what why into it. Oh, what the fuck. Yeah, it's not working for 15 and for 5 first. 1, 2, 3, 4, 5. This 10 says initially 5 and I'm saying if the parity is different, yes. For the right direction. Yes. Add varieties are different. Sum plus equal to, oh wait, just waiting. Varieties are different, then I'm not going to say this. Sum plus that index, but before that I should initialize my sum with first index. But that is not gonna work. Now, still 15. Why still 15 and 5? Because my answer is 5. Yes, so that means here is the max. This is into mean versus what? Wait, what? Let's just into x. See, this condition is not working. Oh, okay, wait. Yes, there is no such conditions yet. I will take one. These conditions. Then I'll just gonna say sum plus equals to. You can just do like this, but it's not good. After the loop also, you can just say I have calculated sum, so answer of x. What's max of sum? I can do like this also. Or one thing you can do. You can make this line as in here also. 99, so 99. Why 103? How 103 people? Why? How? Different for this 8. This is 8. This condition. Why 7? The maximum is 4 initially. Influence of 4, 1, 0. So, I got it. So, just so I'm not okay. I got it. I'm not excluding this mention kind of thing. For that, I have to run two loops now. That's the problem. Or what I can do, I can use that sliding window thing. That this is working. I this okay. That first thing, this something absolute element should be less than that. How? How I don't know, man. I did. I have give it pretty, pretty much time. I did hint. What does the parity of adjacent element tell us about the varied array can exist? What does the parity of adjacent elements tell us about where a varied array can exist? What does it say? It says I couldn't get it here. How to adjacent element with same parity divide the array into independent segments for finding the maximum subarray. It divided into two parts. Divided into two parts. Morphic Kadam's algorithm. Oh, अच्छा Kadam's algorithm. Okay. This question is something. Kadam's algorithm. I never actually this type of doubt. I have this type of doubt. Like, uh, what should I do when, like, for Kadam's algorithm, I only solved one type of question. That when the maximum sum and we have to find, right? Okay, maximum sum of a subarray which includes negative integers. Kazan's algorithm. Yes, okay. But this question is Kazan's algorithm with parity thing, right? That's why it says. Oh no, not. That's why it says modify Kazan's algorithm to restore the subarray when the bad parity comes. Okay, Kazan's algorithm. I need a check. The algorithm states okay, okay. For alpha, if sum plus equals a of I and mx equals max of max mx comma sum, and what we just say, we just say if my sum is less than 0 anytime, just update it and make sum as 0. This is Kada's algorithm obviously, and but I want what answer. But this is Kada's algorithm, but there is one catch, which is what, which is parity wala thing, right? So how to handle the parity one? Till now the answer is my mx, and it's my inside my mx. So I have to include the parity wala thing. So I'll just gonna say, mm, if both are same parity, mm, so I can just do Kada's algorithm. Else I'm just gonna say, else I'm gonna make this sum as, but I don't know Kada's algorithm will gonna work if I did this type of thing, like if I make it one, and like I don't know Kada's algorithm will gonna work if I do this, because I never learned Kadasika. I only solved one problem in Kadasika, which is the standard one, like summary one. I do understand that, but I don't know it will gonna work if I modify anything. So I think for this problem at least I need to check the tutorial. This is all for today's video. I think, yeah, I can't solve it. but yeah, I'll still gonna post it because I give it a try, and that's okay. That's fine. That's normal. I think. Yeah. So yeah, bye.